Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week. I'm James Titko. This week's question comes in from listener Janie.
Hello Naked Scientists. My name is Janie, I'm from Bedfordshire and I have a question about wind turbines. I understand how old-fashioned windmills work because the sails or blades have a large surface area for the air to push against, but modern wind turbines have narrow blades with hardly any surface area. Surely these blades just slice through the air. Can you explain how they work, please? Thank you.
Thanks for that question, Janie. Wind turbines and old-fashioned windmills are both designed to capture wind energy, but advancements in technology have led to more efficient designs over time. Here to help me answer your question is Professor of Engineering at the University of Durham, Simon Hogg. Hello, Simon.
Hello.
If you were just to look simply at an old-fashioned windmill and a wind turbine, the design of a modern blade is a bit more complicated. Can you walk me through it and the thinking behind, the physics behind why it leads to more effective harnessing of wind energy?
Yeah, there are two things that really determine the amount of power that a wind turbine is able to extract from the wind. The size of the turbine, so the swept area of the blade, the circle within which the rotor rotates, the bigger that is, the more air the turbine interacts with, the more power you get. And then the other thing is the amount that the air is deflected. So I don't recommend you do this, but if you're driving a car down a road and if you put your hand out the window of the car, and then if you tilt your hand such that you deflect the airflow downwards, what you feel is a force on your hand pushing it upwards. And that's in effect all a sail or an aerofoil does. It's responsible for deflecting the airflow to create lift. And the extent to which it's able to do that depends upon the careful design of the aerofoil. So on modern wind turbines, there's an awful lot of engineering design and innovation that goes into the shapes of the aerofoils on the blades that are used in order to maximize the amount that they're able to deflect the air. Whereas on older designs of windmills, they are by no means as efficient. If you look at the blades, they're not aerofoils, they can be sails or even wooden structures, much more basic designs and therefore much less efficient.
Interesting. And while I've got you, another thing that will always strike you if you look at a wind turbine is the consistent number of blades. It always seems to be 3, whereas a traditional windmill, you may see more. Why is that?
So imagine that we didn't have to worry about unbalanced effects, and imagine that you had a wind turbine with just one blade on it. Quite a large proportion of the air will just pass straight past the turbine through the area where the blade is going to rotate at some point in the future, but not deflected at all. So that's not going to be a good aerodynamic design. But the number of blades you need depends upon how fast the blades are going, because clearly the faster the blade is sweeping round, the greater proportion of the air that's flowing through the turbine is going to be affected by that blade. And you may not realize it when you look from the ground, but typically the big wind turbines that you see now when you drive around the UK or when you look offshore at the turbines that are there, the blade tips are doing around about 200 miles an hour. So they're actually going very fast. And that's why you only see 3 blades. There are some designs that you'll see in the UK, some smaller turbines that only have 2 blades, but 3 seems to be the optimum number. Yes, if you had 4 blades, the turbine might be a little bit more efficient, but then you've got to pay all the extra costs of the additional blade and then handling the extra weight that puts on the structure, all of which puts up the price of the turbine. So it's always a balance between the efficiency and the performance of the turbine and its cost. And 3 seems to be about where the sweet spot that balance sits. Look at aircraft propellers. There you often see 2-bladed ones, sometimes 3, sometimes 4. It's the same reason.
There you have it, Janie. In some cases, bigger is better. Thank you to Simon Hogg, Professor of Engineering at the University of Durham, for helping us with that question. Next week, we're answering this question.
Hi, Dr. Smith. Are there stars not a part of a galaxy?
And you can have your say on that one over at nakedscientists.com/forum. And be sure to drop us a line if you have a question of your own. It's chris@thenakedscientists.com. Until then, from me, James Titko, thanks for listening and goodbye.
Question of the Week is part of the Naked Scientists podcast. Look us up online at nakedscientists.com.